Part 1.
You will hear a conversation between two friends, Ayan and Pratima. Ayan is visiting Mumbai, where Pratima lives. First, you have time to look at questions 1 to 3. Now listen carefully and answer questions 1 to 3. Hello, this is Ayan. Can I please speak with Pratima?
Hi, Ayan. Good morning. No, good afternoon. Nice to hear from you. How have you been?
Hi Pratima, I'm fine. What about you?
Same here.
I have the next Friday off, so I'm planning to come to Mumbai for a weekend trip.
Oh, that's great news. Let's meet over lunch once you land in the city.
I would love that.
Have you been to Mumbai before?
No. Actually, this is my first visit and I'm hoping you could help me plan my trip.
Sure, no problem. What is your flight schedule?
I have booked an evening flight to Mumbai for Thursday and then I have an early morning flight back home on Monday, which leaves me with 3 days to explore the city.
Great. It seems you have enough time to make the most of your trip. And where would you be staying?
Before you listen to the remaining part of the recording, you have 30 seconds to read questions 4 to 10. I have booked a hotel in Juhu because I wanted to be near the beach.
That's great. Juhu is one of the posh areas of the city, and it's pretty close to the major shopping districts and cafes. Not to forget the famous Juhu beach, where you can get some delicious pav bhaji.
The beach and the pav bhaji are already on my to-do list. What else is nearby?
There is Prithvi Theatre, named after the famous Prithvi Raj Kapoor, where you can go to watch a play. I think they are staging one of Shakespeare's comedies next weekend. There is also an open-air cafe and a small bookshop which you can visit.
Sounds great. I'll check their schedule online.
And since you are a first-time visitor, I'm sure you'd like to sightsee a bit. You have to see the Gateway of India, which is right next to the ocean. You can also go book a slot for some leisure sailing with the many boat clubs that have their stalls set up nearby.
Really? That sounds thrilling. I have never gone sailing before. But I hope it's safe because I don't know how to swim.
You will be in good hands, don't worry. These boating clubs are run by certified sailors with years of experience and expertise.
Oh, good. That sounds reassuring. I was also thinking of taking a road trip from Mumbai on Saturday and visit some of the less crowded, picturesque locales around the city.
Oh yes, you should. I can give you a couple suggestions and you can take your pick. Firstly, there is always good old Lonavala Khandala. The Twin Hill Resorts happen to be one of the best places to de-stress and relax. It's a lovely drive up to Lonavala Khandala amidst lush green hills, about 90 kilometers away from Mumbai. There are many places to visit there, like Duke's Nose, Korigad Fort, Tiger's Leap, Lohagad, Bushi Dam, Bedsa Caves and Lonavala Lake. If you're feeling adventurous, you can also go camping and trekking. But always remember to carry your umbrella, raincoat and rain shoes. It rains very frequently over there.
That sounds so enticing. I feel like dropping everything and running there right now. What are the other suggestions?
Next is Matheran. Perched atop the Western Ghats, Mathiran is one of the oldest hill stations located about 83 kilometers away from Mumbai. The vibrant green pastures, serene and quiet environment makes Mathiran a perfect weekend retreat. A ride on the Neral Mathiran toy train is a must as it snakes its way through the Ghats. Simply walking around Mathiran and trying out local Marathi cuisine is extremely refreshing. My final suggestion is Alibag. Located around 95 kilometers away from Mumbai, Alibag can be reached either by road or via ferry. It is a coastal town in the Konkan region and is the perfect place if you want to try out water sports or simply laze around on the pristine sandy beaches of Alibag or Varsoli. If you are interested in some history, then Alibag will give you a taste of that too. It has the remains of a 17th century island fortress, Colaba Fort, an old Portuguese fort called Corlai Fort, and the grandiose fortress of Murud Janjira. So, which one would you like to visit?
Oh, wow! Now I am entirely confused. They all sound wonderful, but unfortunately, I don't have time for all of them. I think I will go to Lonavala Khandala. I'm craving a quiet vacation with a view of the hills.
That is the end of part 1.
You now have half a minute to check your answers.
Now turns to part 2.
Part 2.
Before you listen to the audio, check questions 11 to 20. You have 30 seconds for this. So, Sakshi, what are you planning to do after finishing school?
I'm hoping to study medicine because firstly, it's been my dream since childhood. And secondly, if you have a degree in medicine, you won't be unemployed ever. But the tough part is getting into a medical school. And I'll need a good AIMPT score.
How confident are you about it?
Well, I can't say I'm confident, but I might get a good rank. And my parents would be very sad if I didn't.
Why on earth should your parents be very sad if you didn't get into a medical school? There are so many other options.
Because both of them are doctors and highly successful in their career.
I don't have a problem. My parents no longer live together, and they are too busy with their own problems to worry about me. But I'm sure you worry about your future. Yes, I do. And for that reason, I've worked real hard for entrance exams. And I'm hoping to do well enough to get into a top university.
What subject?
Economics?
Why economics?
Because after graduation, I hope to do masters from a good B school. And I would like to specialize in finance. And what about you, Amandeep?
First, I thought I'd get into computers. But after studying computing in 12th grade, I feel it's not my cup of tea. I'd like to study modern history. I think humanities offers a broad education on world affairs, and history is my first love.
But from the point of view of employment...
It's not totally hopeless either. One can think of public administration or academics. Also, it's less competitive to get in.
But Aman, you don't have to worry about grades. I'm sure you will do very well.
Yes, I really don't think I'll do too badly. And Kabir, what about you?
I've taken entrance tests at a number of engineering colleges in Bengaluru. I'm aiming to join one of them and study mechanical engineering. Hopefully, I'll make it. You see, I love making things with my hands. My room is bursting with contraptions made out of DIY kits. I didn't know you are leaving Delhi so soon. Well, my dad works for a private bank and we are moving back to our native place, Bengaluru, when his tenure ends next month.
That is the end of part 2.
You now have half a minute to check your answers.
Now turns to part 3.
Part 3.
Before you listen to the audio, check questions 21 to 27.
Thanks everyone for coming along. Today I am going to talk about a star in our kitchen, the induction cooker. How many of you have it in your home? Please raise your hands.
Everyone, I guess.
Yeah, almost everyone. Can you please tell me what you find most interesting about it?
It cooks really fast.
I find it amazing that the pot doesn't get hot even when the water in it is boiling.
Okay, I'll cover both your points in my talk. That is, how it cooks so fast and why the pot isn't heated. I'll also talk about the energy efficiency of this wonderful gadget. But first, let's see how it works. All electrical machines like motors or generators lose heat through something that is technically known as magnetic hysteresis or eddy current loss. In fact, a big challenge for electrical engineers is to reduce this loss. But in induction heating, they multiply the eddy current loss to generate more heat. If you look at the schematic diagram on this slide, you'll see that the main part of an induction heater is a specially designed induction coil. You know what a coil looks like. Can you point it out on the diagram?
The bottom half of the diagram at the center.
And where do you see the main power supply circuit?
Right underneath the coil.
Right. And the cooling system?
At the bottom right corner is a fan. I guess that's what you're looking for.
Absolutely. Where do you see the control and timer circuit?
Top right.
And top left is the ceramic cooktop. The device has a high-frequency oscillator too, but you don't see it in the diagram.
Before you listen to the rest of the audio, check questions 28 to 30.
The electromagnetic coil is just under the ceramic plate on which we place the cooking pot. It produces a strong, high-frequency electromagnetic field. Whenever a pot made of a magnetic material like iron is placed over this coil, a high-frequency magnetic field passes through the pot and generates heat in the substance kept within the pot, thanks to the eddy current loss. And this is the reason why the pot doesn't get heated. Rather, it becomes a part of the heating equipment. In conventional electric or gas stoves, heat is first transferred to the pot through contact or proximity, and then it passes on to the food. In the process, a significant part of the heat energy is lost. But nothing is lost in the universe. The so-called lost energy just makes the environment hotter. According to a technical document published in 2001 by the US Department of Energy, DOE, The efficiency of energy transfer for an induction cooker is 84%, as against 74% for a smooth-top non-induction electrical unit. This translates to approximately 12% saving in energy for the same amount of heat transfer. However, independent tests conducted by research labs show that the actual efficiency of induction cookers is usually between 74% and 77%, and it occasionally reaches 81%. Therefore, the 84% induction efficiency reference value should be taken with caution. In comparison and in agreement with the DOE findings, cooking with gas has an average energy efficiency of about 40%. So, for environmental considerations, induction heaters are preferable to gas burners. However, does it mean that all induction cookers are equally environment friendly? The answer is an emphatic no, because the ultimate environmental impact of any stove doesn't depend on the units of electricity it consumes, but on the environmental cost of producing those units of electricity. Electricity itself is produced in many different ways, and every plant contributes to global warming differently. For example, solar or wind electricity does not produce any greenhouse gases at all. Therefore, if you ran your induction heater with solar power, you wouldn't harm the environment at all. However, coal-fired electricity generators are one of the biggest producers of carbon dioxide, the most common greenhouse gas. And among these plants, different ones operate at different efficiency levels. It has been calculated that if the plant emits less than 435 grams of CO2 per kilowatt hour, the greenhouse effect of an induction cooker will be lower than that of a gas cooker.
That is the end of part 3.
You now have half a minute to check your answers.
Now turns to part 4.
Part 4.
Before you listen to the audio, read questions 31 to 40.
Kepler mission. The centuries-old quest for other worlds like our Earth has been rejuvenated by the intense excitement and popular interest surrounding the discovery of hundreds of planets orbiting other stars. There is now clear evidence for substantial numbers of 3 types of exoplanets: gas giants, hot super-Earths, in short-period orbits, and ice giants. The challenge now is to find terrestrial planets, that is, those 1/2 to twice the size of the Earth, especially those in the habitable zone of their stars, where liquid water might exist on the surface of the planet. The Kepler mission is specifically designed to survey our region of the Milky Way galaxy to discover hundreds of Earth-size and smaller planets in or near the habitable zone, and determine the fraction of the hundreds of billions of stars in our galaxy that might have such planets. So, what exactly is Kepler? Kepler is a space telescope that measures the dimming of stars as planets pass in front of them, blocking just a little bit of that light from reaching us. Named after astronomer Johannes Kepler, the spacecraft was launched on March 7, 2009, into an Earth-trailing heliocentric orbit. Kepler's data reveals planet sizes as well as their distance from their parent star, like our Sun. Together, this helps astronomers to understand whether these planets are small and rocky, like the terrestrial planets in our own solar system, or how much light they receive from their parent star. In turn, this provides clues as to whether these planets that we discover might be habitable or not. Objectives of the mission. The scientific objective of the Kepler mission is to explore the structure and diversity of planetary systems. This is achieved by surveying a large sample of stars to determine the percentage of terrestrial and larger planets that are in or near the habitable zone of a wide variety of stars. Determine the distribution of sizes and shapes of the orbits of these planets. Estimate how many planets there are in multiple star systems. Determine the variety of orbit sizes and planet reflectivities, sizes, masses and densities of short-period giant planets. Identify additional members of each discovered planetary system using other techniques. Determine the properties of those stars that harbor planetary systems. Transit method. When a planet passes in front of a star as viewed from Earth, the event is called a transit. On Earth, we can observe an occasional Venus or Mercury transit. These events are seen as a small black dot creeping across the Sun. Venus or Mercury blocks sunlight as the planet moves between the Sun and us. Kepler finds planets by looking for tiny dips in the brightness of a star when a planet crosses in front of it. We say the planet transits the star. Once detected, the planet's orbital size can be calculated from the period, how long it takes the planet to orbit once around the star, and the mass of the star using Kepler's third law of planetary motion. The size of the planet is found from the depth of the transit, how much the brightness of the star drops, and the size of the star. From the orbital size and the temperature of the star, the planet's characteristic temperature can be calculated. From this, the question of whether or not the planet is habitable, not necessarily inhabited, can be answered. Target field of view. Since transits only last a fraction of a day, all the stars must be monitored continuously. That is, their brightness must be measured at least once every few hours. The ability to continuously view the stars being monitored dictates that the field of view, FOV, must never be blocked at any time during the year. Therefore, to avoid the Sun, the FOV must be out of the ecliptic plane. The secondary requirement is that the FOV have the largest possible number of stars. This leads to the selection of a region in the Cygnus and Lyra constellations of our galaxy as areas of study. Kepler's second mission, K2. The loss of a second of the 4 reaction wheels on board the Kepler spacecraft in May 2013 brought an end to Kepler's 4-year science mission to continuously monitor more than 150,000 stars to search for transiting exoplanets. Developed over the months following this failure, the K2 mission represents a new concept for spacecraft operations that enables continued scientific observations with the Kepler Space Telescope. K2 became fully operational in May 2014 and is expected to continue operating until 2017 or 2018. Using the transit method to detect brightness changes, the K2 mission entails a series of sequential observing campaigns of fields distributed around the ecliptic plane and offers a photometric precision approaching that of the original Kepler mission. Operating in the ecliptic plane minimizes the torque exerted on the spacecraft by solar wind pressure, reducing pointing drift to the point where spacecraft attitude can effectively be controlled through a combination of thrusters and the 2 remaining reaction wheels. Each campaign is therefore limited by sun angle constraints to a duration of approximately 80 days.
That is the end of part 4.
You now have half a minute to check your answers.